All right, hey guys, here is lesson 21. Lesson 21 is on solving systems using substitution. Now, we already worked on systems in lesson 15, but I taught you the method graphing. So let's review really quick. We can have one solution, and that is when I have two lines that intersect at a specific point. I can have infinite solutions. And that is when I have two lines that are basically on top of each other, and so they create infinite solutions. Or third, the only other possibility is no solution. And I don't know if you remember, but that is when I have parallel lines. So today, I'm going to teach you a new method. Okay, so instead of graphing, I'm going to teach you this new method called substitution. And it's not difficult, and you do need to become familiar with it. Because sometimes this method is the fastest. So let's start in with how to do this. So here we are going to solve these systems using substitution. So 2y minus x equals negative 6. And y minus 2x equals 1. Now, substitution means that I'm going to substitute the value of one equation into the other. And the easiest way to do this, get one variable all by itself. Sorry, that should be an F. So I'm going to do that with this one. If I add 2x to each side, I get y equals 2x plus 1. And I hope you can see that that is what I did. I added 2x, and you know what, I'm going to write it a little bit higher so that we have room for everything. Okay, and then I'm going to substitute. So I'm going to substitute this expression into the other equation. So here we go. I'm going to write 2y minus x minus 6, and I'm going to substitute 2x plus 1. So hopefully you can see that I am substituting this expression into the other equation. And sorry, this should say equals negative 6. My apologies. So now I'm going to distribute, right? 2 times 2x is 4x. 2 times 1 is 2. Minus x equals negative 6. Now I see some of you doing the opposite when it's on the same side of the equal sign. When it's on the same side, when all of these terms are on the left, I'm simply going to combine like terms. So 4x minus x is 3x. I'm going to subtract 2 to the other side, and I get negative 8. I'm going to divide by 3. And I get x equals negative 8 over 3. Now what do we do? Well, now substitute this in 4x to find y. So now that is what I'm going to do. And you can use any equation, and I'm going to keep my fraction. So I'm going to actually substitute it into here. Y equals 2 times x plus 1, but I'm substituting in a negative 8 thirds. That gives me negative 16 thirds plus 1 which would be 3 over 3, and that gives me negative 13 thirds. So my answers are x at negative 8 thirds and y is negative 13 thirds. So let's try that again. I'll try to get my work to flow a little bit better than what I did. I kind of write all over instead of like vertically or horizontally. So let's try another one. We're going to solve by substitution, okay? Solve using substitution. So y equals x minus 2 and 2y equals 2x minus 4. Okay, so step 1, I'm going to substitute x minus 2, so I'm plugging in. Look, I already have this guy by itself. That's when substitution becomes so beautiful. This y right here is already by itself, and I'm going to substitute it in to here. So 2 parentheses y equals 2x minus 4, and I'm going to substitute in x minus 2. I'm going to distribute. Okay, now you could stop here. These expressions are identical. So if you were to graph these would be the same. Now if you want to keep going because you can't see that, I would subtract 2x. And I get negative 4 equals negative 4. Notice there are no letters left, so there are no variables. And it is a true statement. So the answer is infinite solutions. Next one. I like to do lots of examples for this one because I want you guys to be really confident solving these. So next one, 3x plus 2y. Well, no, that's never going to happen. So negative 2x plus y equals negative 2, and y equals 2x plus 2. Okay, so again, we're going to be solving using substitution. So because the bottom equation already has y by itself, I'm going to substitute this expression, and it's a y equals statement, so I'm substituting it in for y because I know what y equals. So I'm going to rewrite the top, negative 2x plus, and I'm going to substitute in y. And so I'm substituting in 2x plus 2. I'm going to simplify, so negative 2x plus 2x plus 2 equals negative 2. These become 0, so I have 2 equals negative 2. Now this is false. And there are no variables left, so no solution. Okay, now I've done an example of each kind, so we're going to jump into our lesson practice. And it's on page 149 and 150. So part A, they want us to solve the following using substitution. They have y plus 3x equals negative 4, and 3y minus 2x equals negative 2. Now, here are my steps. I'm going to get the first equation by itself. So y plus 3x equals negative 4. I chose this one because y has nothing in front of it but an invisible 1. So I'm going to subtract 3x. So y equals negative 3x minus 4. So there's step 1. Step 2, I'm going to substitute this expression into the other equation. Okay, so step 2, I have 3 times y minus 2x minus equals a negative 2. And I'm substituting negative 3x minus 4 right in there. Then I've got negative 9x minus 12 minus 2x equals negative 2. I'm going to combine like terms, so that's negative 11x. And I'm going to add 12. And I get 12 minus 2, I get positive 10. Okay, so then I'm going to divide by negative 11. And x equals negative 10 over 11. Now, step 3. I'm going to plug this value into any equation for x. So plus 3, I'm substituting. There's the equation in the top, and I'm substituting the value of x inside. So I'm going to move this over here. Y minus 30 over 11 equals negative 4. So I'm going to add this to both sides so you can see all my work. Okay, so this is gone. I have to rewrite this to have a common denominator. So this becomes negative 44 over 11 plus 30 over 11, and y equals negative 14 over 11. And so those are my answers. Let's try B. B was 3y equals 12 minus 6x, and y equals negative 2x plus 4. Now, if I was you, what would I do? I'd pause my video, and I would say, okay, I have a letter by itself. So I'm going to substitute this into the other equation for y, work it out, then play and check it with mine. So you can check yours now. So 3 parentheses, what I'm substituting in equals 12 minus 6x, and I'm substituting in negative 2x plus 4. That gives me negative 6x plus 12 equals 12 minus 6x. Now, looking at this, these are identical. So I already know that these are identical lines. So I would write infinite solutions. If you would like to keep going because you can't see that, so these both zero out and I get 12 equals 12, which is true. So I have infinite solutions. Either way, whatever, you want to keep going, or if you can just look at it and see it, awesome. Moving on to the next one. So I believe we're on part C. Y equals 12 minus 6x. Oh, sorry, nope, that's wrong problem. I'm writing B down again because I'm silly. Y equals 6x minus 5, and then you have 2y minus 10 equals 12x. So I'll get you started and you try it. I have a variable that's already by itself, so I'm going to substitute that in to the other equation for y to see what I get. And so I'm going to do that up here. 2 parentheses y minus 10 equals 12x, but I'm substituting in 6x minus 5. Then I'm going to distribute, so 2 times 6x is 12x. 2 times negative 5 is negative 10, minus 10 equals 12x. Now I'm going to combine like terms, so this gives me 12x minus 20 equals 12x. If I subtract, I get negative 20 equals 0, and this is false. So the answer is no solution. D. 3y minus 7x equals 5, and 4x minus 9y equals 2. Now this is going to be a difficult one because you're going to get fractions, but we're going to get rid of those fractions. Or we can if you'd like. It's up to you. So here we go. I'm going to get one of these variables by itself, and it doesn't matter which one. So 3y equals 7x plus 5. Then divide by 3. So y equals 7/3 x plus 5/3. Okay, so I'm going to substitute this into the other equation for y, and I'm not going to be a baby about fractions. Okay, we can do this. So 4x minus 9 equals 2, and I'm substituting in 7/3 x plus 5/3. Okay, so that gives me 4x minus 63x over 3 plus 45 over 3 equals 2. Wow, you know what? You guys, that is beautiful. It can be simplified. 4x minus 21x plus 15 equals 2. I'm going to combine like terms. Okay, I hope you can see that. And I apologize, this should be a negative 15 because a negative times a positive is a negative. So if I add that, I get 17. So x equals a negative 1. And then I'm going to plug that back into any equation. So 4 times negative 1. I should do all my subbing in black. Minus 9y equals 2. And I can plug this into any equation. I just chose the bottom one. So that gives me negative 4 minus 9y equals 2. I'm going to add 4. And I get negative 9y equals 6. Divide by negative 9. And y equals negative 2/3. Because a positive divided by a negative is a negative. And I can reduce them. Okay, and we are going to, we'll go ahead and skip, well, we can do E. E gives us a table, and so I'm going to write an equation for the first. So for Corey, I'm going to write y equals 79x plus 733. And you can look at the table, y equals 116x plus 538, and then you would solve this. So I'm going to substitute this into here. So 116x, oh, that's not fair, I'll write it how I've always been writing it. And I'm going to solve, so I'm going to subtract 79x. And I got 37x. And then I'm going to subtract the 538. And I got 158. I'm going to divide by 37. And I got x equals 4.27. So about 4 years. So 2005, because these values right here is the population in 2005. Right? Did I use 2005? Yes. So 2005 plus 4 would be about 2009. And we are done.